Mm. It's not easier. I'm just gonna try program at the bottom. Why is it hanging? It's hanging. Okay, so what do you do? We have a random generator and we have num-trials of trials. What is that? Set to 100. Okay, it stopped a bit sooner than that. And we should get a vector A by calling generate random vector. Does this work? Yeah, okay, which returns double vector of doubles. Of n vectors, we have a 5-dimensional vector here. And fills that vector with random numbers between 0 and 1. At least it's doing that here. As you can see, Claude wrote this. I ordered it to write it like this, but it uses all kinds of stuff that I wouldn't do. Calculate the length of the vector. I mean, it has random arguments, coordinates, what is it? But we wanted a normalized vector, so just divide everything by the length, and then the result will be a vector with a length of 1. So now we have a random n-dimensional vector with a length of 1, which is returned here. Then the it's a bit silly what it's doing here, but okay. The theoretical variance is just the variance of probability density function or probability distribution. We just added n uniformly distributed random numbers that are independent is simply the sum of the variances of each number, and the variance of a single uniformly distributed number. From my head, I think it's uniformly distributed between minus b and b. And then the variance is b squared divided by 3. And if you add a few of those random numbers and they're all independent, then the variance is just a sum of that. So what we should get here is for each coordinate of the vector A, we just take the coordinate and we square it, and then we add all those. That's the inner product of a vector with itself is here is yeah, it's a bit stupid that it's called A here, but my A vector has we talk about that as having coordinates like or elements like A0. Not bad. So if each of these are basically you're going to multiply these with an uniform distribution between minus 1 and 1. So then the result is a uniform distribution between minus AI and plus AI. And then the variance of that is AI squared divided by 3. And then we just need the sum of that. So what you want to end up here with is A0 squared plus A1 squared plus A2 squared plus A3 squared plus A4 squared and so on, and then all divided by 3. That would be the theoretical variance. I can't explain. Okay, and then we calculate the dot product between the vector A and the vector with n uniformly randomly distributed things, which is being done by this symbol dot product here. So this just runs over all the coordinates. I don't know, I'm having a brain fart here. I think elements are better now. So I'm run over all elements of the vector, n of them. All, yeah. And then we calculate dot product, so you just get the first, well, or coordinate, I don't know. The first coordinate times the first coordinate of that random vector, and they are all independent random numbers. So just this gen is just a random number between minus 1 and 1. So those would be all the coordinates of the random vector, called. And then the sum is the dot product of those two. Maybe I should explain a little bit more. I mean, I'm like, yeah, I can explain it, but it's hard stuff anyway. So maybe I should just not explain it. It's actually in the description. If you look in the I wrote a lot of stuff in the description of the video. So you scroll down and you read that, and you know what this is about. Let me just mumble to myself and then at the same time check this code. So again, calculate dot product with the random uniform vector. Yeah, though that's what it's doing here. So that would be a single sample Well, it's called samples, so we push that back to the vector samples. Num samples is like 1,000,000, at least I asked for 1,000,000. Let's see what it made of it. Can't find tag pattern. Very great. 1,000,000, okay. Sort the samples to find the 25th and 25th and 75th percentiles. So all the samples are stored. Yeah, okay, I see. So this the samples vector is 1,000,000 big, and then we just look at the sample that is at 25%. Use that value to guess what the width is here. Calculate the ratio between empirical and theoretical ranges. Well, you only have a theoretical range for when it is uniform. So a single variable, for say n is 1. Or when all these a's have the same size, then it would be just the Irwin-Hall distribution, which for a lot of n's, then even also n has to be large, and then it would be a normal distribution, and then this is the theoretical width that we would have. Yeah, so it's a bit far-fetched. Not really accurate for small n, this. So I'd hardly call it theoretical. So the ratio of empirical to theoretical ranges. To be honest, I'm not really interested in this. I just want to see the value and then see that it doesn't change much. The result for this trial, if a trial less than 5, no, I want to see all of them. So I don't know why it is doing that. That's why it stopped. It wasn't hanging, it just stopped. It just stopped printing. So we print which trial it is, and then we print the whole vector. And then we print the 50% empirical range, and I really don't care about the theoretical ranges nor the ratio. And this might well be printed on the same line, or not. Okay, so then what it's doing here, after everything is done, calculate statistics across all trials. Average ratio, so you need a range ratios thingy. We did push that back. Yeah, let's just store the empirical range, really, not this ratio. Just gonna delete this completely. Average is of course the sum divided by the number of trials. Calculate the variance. And ratio minus ratio and times that. Yeah, that looks like a square, but okay. And then we divide that by number of trials divided by 1. Summary across number of trials, okay. Average ratio, yeah, we didn't do that, so this is more like the average range, average 50% range. Ratio is more like range, whatever. Here's here too, actually. Standard deviation, okay. No, and I sorry, but I think it's a newbie thing, so no return 0 from new. Make ranges. What the hell? Why not just ranges? It was a range ratio. Okay, I should rename that. Damn it. Let's just do an undo. There, stop. Undo. Fuck off. Got a notification. 50%. It's damn slow. Okay, so the idea is that this number is kind of independent of the vector A, because we have a random vector A now. These are, well, that's a five-dimensional vector, but still. And then the empirical range is, well, basically the same anyway. To be something between 0.8 and 1. Let's see, we have one that's below 0.8. I think the theoretical limit is 0.79 or something. We had 100 trials, so let's just wait, and then we can see the average and the standard deviation of it. Average 0.8445 with the standard deviation of 0.038. Interesting. Okay. Can leave it that. So then we can approximate this by just calculating the variance of summing the A squares, and then just always using this as a factor to get the 50% range. although it doesn't even matter really. It's just some scaling factor. The point is that, now I'm thinking about it, don't I need to take the square root? Let me see what I wrote in the description of the video. Yeah, so the value is could be as low as 0.7788 if all the a's are the same. I should not see that happen. Yep, let's look at the code again. So I want to find the width within which 50% of the samples fall, which is given by this range here. To find this range, the variance here is always 1 because normalize the vector A to 1. So we have a sum of the square of independent random variables between minus a and plus a. Well, minus ai and plus ai for each of the coordinates running I from 0 to n minus 1. And then the variance is that each of these AIs squared, summed, divided by 3, which is 1 divided by 3. Because the length of the vector is 1, then all the coordinates squared summed is 1. You can see that here as well. Yeah. So the theoretical variance is just always 1/3, because this is going to be 1. It's just printed out here. Theoretical variance is always 1/3. Where is it calculating it? I think here, dot symbol. I'll put it there or something. When you want to talk about the vector, let's say, I think about, do I have to take the square root of variance or not? It is proportional to the absolute value of the limit. Either the dominant a coordinate or the absolute value of all of them, if they are all equal in the two extreme cases of a uniform distribution, and then what leads to a normal distribution for large n. And that seems to correspond to the length of the vector, I would say. No, it doesn't. Shit. Nope, does not. I think. absolute value of IM. It's some factor times that. And what is that? That is I swear I invented this, but now I'm not seeing it. Let me make a copy. It's in the description, but I'll make a copy of it. Paste it here. So it's looking at this. So these are just two random examples. The case where all the A are equal. Maybe I should do that, like so we want to have one of the coordinates of the vector A be completely dominating the rest. Means we just set 1 to 1, and the length must be 1, so we set one coordinate to 1 and the rest to 0. Then the length is 1, and that this one is infinitely larger than all the others. So instead of calling this function, I'm going to define A as being that. Oops. And the top. I'm not sure that will work actually for a vector. Probably not. No, the length is 5. I'll just fill them in. So in this case, we have the dot product of this vector with uniformly distributed values between -1 and 1 is going to be one where this one is between -1 and 1 because you multiply it with 1, and this one is just always 0. So we do some random value between -1 and 1 times 1 plus some random value between -1 and 1 times 0, which is 0, and then again, so plus 0, plus 0, plus 0. So in the end we just end up with a sum of a uniformly distributed random value, uniformly distributed between -1 and 1. And the variance of that is going to be 1/3. And then we do generate empirical samples where we actually generate these dot products. So each sample now is just a uniformly distributed value between -1 and 1. And then of course we'll find that that is between -1/2 and +1/2. I mean, if 100% is between -1 and +1, so half of it is between -1/2 and +1/2. So this is going to be -1/2, this is going to be +1/2, and then we do a half minus -1/2, So minus minus a half. So that is half plus a half is 1. So the empirical range is 1. Okay, that's confusing. I would say that has to be a half. No, it's 1, yeah. Because the total range is between minus 1 and 1 is 2. And then half of that is 1. So if the million is large enough, then this is going to be 1 every time, and we push back a lot of 1s here in the 50% ranges. So it just print 1 all the time, as expected. Okay, so far I'm with it. Bit shocked that it's larger than 1, but it's more or less 1 every time. Okay. Now we're going to make all of them equal. So now we have 1 is dominating, and now we want to make all of them equal, and the sum must be 1. So that means that the sum of the squares. So that means that one of them must be the square root of 1/5. It's not that stupid, AI. So that gives 0.8. It's a bit on the large side. Pretty sure that should have been 0.778 or 0.79. Rounded off. No, 0.78, yeah. 0.7788. Isn't it? Why do I get 0.8? It's pretty close, but Oh, it's because n is too small. Yeah, sorry. So if we make n significantly larger, this is going to be as small in the end as 0.7788 for very large n. But for n is 5, I made a list somewhere. It was also empirically, actually, but let's see if we can find that back. Yeah, bang, there it is. So if n is 5, n is 4 is 0.806. So n is 5 is apparently 0.8. That is totally correct. See, if we make n very large, then it is going to go to 0.7788. Let's see if we can get 0.806 back for the n is 4 case. No, you gotta be kidding me. Oh, that's because I used 0.2. Sorry. Yeah, that's my whole vectors are completely wrong. So to do this a little bit more carefully here. This one. God, this is fucking smart. I'm really impressed by Copilot every now and then. I mean, if you're watching this and you have no idea what I'm talking about, imagine the Copilot, this AI, it just understands exactly what I'm doing. It's just took a push. Oh, you mean this? Yeah, yes, I did. Thank you. Yeah, so now we get 0.806 back. That was this one. Nee, this one. Nee, this one. Nee. I got it. I'm sure I get it. It's gonna go here. Yeah, I have it. So that one. 0. And here's another one. And another one. So then you have the two limits for one is completely dominating the others, or they are all equal. And then if you take random values, it's somewhere in between, of course. So that would be this case. And then, yeah, then we do get values between, in this case, 0.806 and 1. It's a limit case here. So they're basically all the same amplitude here. 0.4, 0.5, 0.5, 0.5. So more or less the same size, and then we get that one. And if you get something that is close to 1, then 1 is dominating. So this one is 0.9 and the rest is significantly small. That's how it works. Yes, also one is dominating, the other one, 0.9. Oh, this one. 0.97. But the point is, we are calculating the variance of A, and then from that I want to have the 50% range. So you're gonna use, I don't know, I could use this, but maybe sometimes we have more epsilons. So it doesn't really matter what you take. I mean, I could just use 0.8 and be done with it. If you make n larger, does depend on n. No, I don't care. Let's pick some number, and then how do I get to the 50% range? Okay, and this is where my brain stopped. So this comment belongs to something where the vector is has a size of n plus 1. So So you should replace all the n's with n plus 1, replace all the n plus 1s with just n to correspond to the program here. Let's just use some logic. So if all the a's are scaled up, all of them, with a factor of 2, then all the squares become 4 times as large, so the variance becomes 4 times as large. But the width is, of course, just twice as large. Therefore, we have to take the square root of the variance. And then you get a sum vector. So I want to have that vector, vector, which is the empirical range. We want to find empirical range as, no, you want to find a vector that I will have to calculate, that I have to multiply the variance with to get the empirical range, the 50% range. And which means that I have to divide this by the variance. Sorry, the square root of variance. Square root of, yeah, indeed. How on earth does it know that? That's just scary. Let's say store the no, it's a ratio again. Damn it. The hell? So now if you have the variance, you can just take the square root and then multiply that with this value. And then we get the empirical range. That needs a good estimate for that. Just use a square. This is not correct. This is not correct. Well, actually it is, sorry. No. B is the half of the width. So range runs from minus b to b. So the width is 2 times b. So if b is this, then the width is actually just equal to the absolute value of am here. So I'm using AM here because this is not for normalized vector A. So this is really having an AM here and the rest being 0. Since we pick 1 here, I might as well say that it is 1 squared, or the sum of 1 squared. Let's fill that in like that. And then the AK here, well, this is 1 divided by square root of n, right? Okay, we do the same as here. Just writing the variance. It's not. How do we do this? What's the bloody formula for that? I think we should just end up with that number. Need to get rid of this. Although AM is 1 in my case, which is annoying. Just fill it in like that. So that must be gone because this is 1 anyway. So this is gone. And so we have here no AM. It's going to be 1 square root times the square root of n divided by 3. And I'll just fill in here what I need then. Just that number times something times that. Okay, to the absolute value of AK. Yeah, that is 1 divided by, yeah, it's just what it is. Exactly that. Yeah, okay. It's a bit unclear where the formula comes from now, though, but So if you sum yeah, exactly. The central limit theory applies. And we add yeah, and random variables, but these was something special with them. Distribute, no, it's being stupid. So you have n random variables that are all distributed between minus 1 divided by the square root of n till plus 1 divided by the square root of n, meaning that the length of the vector is 1, because you take the square of this. I mean, this vector here is the a, yeah. So the a has like we filled it in here, like this. Where is it? We did fill it in. I deleted it again. At some point you had here the made a vector here where all the coordinates were equal, and then even the copilot understood that it had to be 1 divided by the square root of n for each argument in order to keep it normalized. So the a exists, the vector a then is 1 over the square root of n, 1 over the square root of n, and so on. So the square of that is 1 over n, 1 over n, 1 over n, and the sum is then n times 1 over n is 1. So the length is then 1. And that a is what you see here. So, yeah. And if you add that, then you get the absolute value of that times the square root of the number of things that you add, and random variables divided by 3, and multiplied by this to get the 50% range. This is based on the normal distribution. Yeah, okay. I typed an S and the Copilot knew what I meant. I'm not sure about the variable though, what that is. Square root of the variance should be around that. A second. Sorry. So you have the variance is 1 divided by 3. Take the square root of that. Square root of 1 divided by 3. Yes, we have to divide by that. Divide the empirical range by that. So do 1 divided by that. That is simply the square root of 3. Yep, so that's here. And then multiply the square root of 3 with the empirical value, which is somewhere between a half and 0.7788, or isn't it? I don't know where it got the number from, to be honest. Dubious about this one. Not C++. So we have the variance, which is 1/3 indeed, and I want to get the width here, 50% range. I have to just multiply the variance with, no, I have to take the square root of that. Take the square root of this and then multiply it with something to get that. Well, maybe I meant this. Yeah. I'm sleepy. 1.49. Right. Okay. So. I should change this, I think. So it stores a first order per epsilon. Without actually having epsilon symbols. Just make it turn vector or something. But it's a reference. So I have to store pointers in my vector. Let's define a new integer type, which stands for the epsilon index. And I'm going to use that as the index. So we have to include, let's use, must be a vector, right? So include utils vector. And then we must make a type of that. Math vector, utils vector. What the hell is there now here? Well, it's using vector index. Maybe that has some documentation. Also not. Gonna be kidding me. How the hell can I write these things without any documentation whatsoever? We can just use a random category type for the vector index. Int, no. Utils vector index. Let's call it epsilon. Index. I need a struct. Category. Yeah, so category is just some abstract type. to make different instances of vector index. And vector index is just a wrapper around the size type. So it's an index. So now we defined an epsilon index type, but yes, this is just a size type, but then protected from accidentally being used as an int. Then I want to change this thing here in vector. Oops, not standard. Utils vector, and we store starts to get irritating. I'm distracted by it. No, I want to store this, but it can't store references, so we're going to store pointers. And I'm going to use that as index type. And actually that was correct, but okay, I can also do it like that. Oops. First order. Terms with single epsilon vectors. Or I could make this an array and then know in advance the number of epsilons that we have in this class. So more logical, to be honest. Let's make it an array. This means we need a size, and this must be probably an array index then. Not so sure. Probably I have an array index. Utils array index. Yeah, it's just defined here. So wrap around an int. Yay, we save 30 bits. For the rest, it's the same thing, right? You just text a category as well. Yeah, category. And the utils array then says what it stores, the size, and only then the index. Okay, so I have to insert the size here. Let's call that number of epsilons. Keep shifting this. What the F, man? It still fits on my monitor though. I want to do it. Did you say symbolic? You're talking about const expression. Brilliant. Did it get the 12 right? Not the correct description. Maybe I do it here. The number of epsilons. No. Okay. Yeah, but the name is like literally number of epsilons, so it doesn't describe anything. Put it down here. See how many epsilons do I really have here? the program. Just 10. Okay, so this array storing symbolic expression const pointers with a maximum of number of epsilon. We're using the epsilon index type as the type for the index. Means that the type of first order has changed. This is initializing it to construct a first order object where the zero order is an integer. Yeah, the first order. I would have to see where this is used before I know what to do with it. Just comment it out. It's kind of the same story. Man, this is way too difficult. Let's just go down. This the trick of the assuming that the class already works. A big trick. Okay, so I'm creating epsilon, well, expressions of 1 plus epsilon, but could still do that. If we still do this, and I don't have to change this, that would be nice, wouldn't it? Yeah, I think that would be nice. I'm just gonna keep all of that. This is a nasty evaluation trick. Oh, it's a horrible trick. Would that still work? Is that still going to work? Probably not going to work. Apparently I must be able to assign to the epsilons and then still evaluate the whole expression. So calling evaluate here on the derivative of very difficult stuff. Yeah, I think the whole idea here is that I want to change the class in a way that it is still a drop-in for this code. So I don't want to change anything in this code. Now I think about it. Meaning that this still must work. And that's the only constructor I use as far as I can see. So yes, the first one is an integer, and then the second one is E0 till E9, what the hell that is. Where are those defined? Probably here. For each variable, declare symbol. Clause for each variable, x to x for C0 till. C12 was correct. We also have an E10, E11. Declare symbol is then my x. Doing symbolic symbol and name variables to index. Okay, that's not easy. Well, it's a symbol anyway. It's symbol of that name. Variables. For each declare variable. It's just a name. Oh, it's an enum class. Okay. Then variables itself. Just an array with symbol const pointers. Oh yeah, of course. We turn that into references. So they are symbols. I don't need the symbols. Not for the epsilons. Yeah, I think I don't need the epsilons anymore at all. Like the E something. Then I can't fill them in like I can't make them zero like this though. So I have to specialize my evaluation as well then. What to do? Probably should remove them from this list. Jesus Christ. Started to make big changes and I didn't even commit the last big changes. Sums. Yeah, let's add it as well. It's maybe a separate one. This is just whip on Newton epsilons. And I'll git commit whip. And then let's say we do what the hell is this? Nothing. Maybe we should just delete it. So some cloud generated shit. So remove it. In the end, I should add an actual Clang format to the project. Just not ignore it. Okay, now I can make some serious changes to this file. So it's going to remove all the e's from this list. Which means I don't have the E0 till E9 anymore, so I can't do this. Just delete it. And then, should I not get my first compile error here? Nope, it's not defined. I am. Yes, I do nothing else. It's debatable if it is commendable, but that's the right word. What was I doing? I need an array index now. Array instead of vector. Small error. Class FA does not declare any constructor. Yeah, no, who cares? I commented them out. Oh shit, we have a reference. So I can't just comment them out. Yeah, okay, I'll just... What? Can't comment them out, no. Is that going to give me a hint then? What to do here? We have... yeah. Well, let's uncomment it out then. But I can't pass a first order. Really, I can't. For now, I'm just not going to pass first order. So the zero order becomes a realized constant, whatever the zero order is, so that's some int. And then the first order we can't do. And the common denominator is just 1. The first order is an array, so I do have to fill it, but I'm going to fill it with all zeros. And I think if we do that, that should be sufficient. Or maybe just not mention it at all, and then do that here. So this is an array with null pointers. Now I shouldn't complain about that anymore, because at least we have one constructor. Oh yeah, of course. Everything breaks. Everything breaks. Because the type of first order is now an array, so none of this works. Let's comment it out. If 0, do not use first order, basically means do not declare any member variables, member functions at all. Ta-da! That is the line that I wanted to have my first compile error in. So what this is doing, it's multiplying C3 with X, and that probably works. But I didn't define epsilon 5 plus 1. Therefore, this line did not compile. But if I just comment out epsilon 5 plus 1, does it then compile? Do we get now the compile error in the next line? No. No viable conversion from expression. Okay, this is just an expression. That is correct. And I can't construct an FA from that, which is first approximation. I think that's correct. It should not be possible to do that. So instead, I'm going to construct this thing from this expression. And I have to tell it which epsilon belongs to this. Let's say I'm passing 5. I don't really want to pass 5. I want to pass something that I can use as the epsilon index. I want to pass an epsilon index. So instead I'm gonna pass E5 because we removed E5. And now E5 must be an epsilon index. Well, let's just create it. So we have an epsilon index type, yes. All of them. Top return, top return, top return, top return. Oh, it's too slow. I never got the top. Top. It stops. Brilliant. However, this is the epsilon index type. Oh wait, make C tags. I meant. It's an array index which has to be constructed from. Well, nothing is good, but then we have an undefined thing. So I want to construct it from an int, obviously. So yeah, I'll just pass 0, yeah, right? Is that not what I wanted to do? And then everything else as well. Substitute E 0 to 9 with E backslash 1 backslash 1. So this, instead of multiplying it with a first approximation object that represents 1 plus some epsilon expression value, and 1 plus epsilon, where the epsilon is a symbol actually. I'm just constructing it now from an expression, a symbol expression, and an epsilon index type, saying what the index, which epsilon to use for the floating point round-off error that this multiplication introduces. Which then means that we need to be able to construct it from an symbolic expression, and an epsilon index type. then that would then be this, the replacement for this one. So yes, it starts with an expression, which is then both actually the 0 order and the first order. I mean, I'm going to multiply it with 1 plus epsilon. So it's literally like times the 1 makes the 0 order, and the multiplication with the epsilon then makes it the factor of that epsilon, which is then the first order. Excluding, I have to admit, the epsilon in this case. So instead of calling it 0, well, let's, no, it's not a 0 order. I'm just call it expression. Damn it. Epsilon index, did it fill it in? No, nothing was filled in. The 0 order. So this is what I had. Common denominator was cached 1. I'm so confused. Oh, I forgot to add it here. Yeah, this whole fuck. This is nonsense. Sometimes Copilot is only costing me time, I feel. Can't do the first order here, or what? Why not? Epsilon index. This is bullshit. Well, you cannot assign it like that. Oh, you cannot assign it like that. That is true. Okay, let's keep it then. Yep, this should work. So the construct of the initializer list doesn't mention it, which means that it is using this one, which just fills the whole array with null pointers. And then in the body of the constructor, we set the epsilon index pointer to point to the expression that is being passed. But all symbolic expressions are stored by the library, the symbolic library, and then passed as a reference, but I can just dereference it and store it as a pointer, no problem. Those things have pretty long lifetimes. No, the next error is in 227. I'm listening to good music. I can't show. I was gonna switch it through, but it's not connected to my to OBS at all. What was it? 227? Yeah. Well, this is exactly the same thing. We just want to construct something from this expression and then multiply it with 1 plus epsilon 4. And here again, just multiply with epsilon 3 plus 1, plus 4, plus 1 I meant. So this is again the same thing. Was it E3? It was E3, right? Yeah, E3 plus 1. We're counting down. So then this is going to be E2. So constructed from this expression using epsilon 2. And then again here, now you get epsilon 1, constructed from this expression using epsilon 1. And here is the epsilon 0. So construct this thing from that using epsilon 0. Took a while, but... And here we have the same thing again, using epsilon 9. No, 9. E9. And this one is E8. This is E7. And this is E6. And why the hell is GA, which is using a division and a subtraction, not using epsilons? Hello, Trajan. Oh, it is not using epsilons because I wanted to generate these coefficients here, which we find in a very dirty way. Very, very, very dirty way. The next compile error is then here, I think. Well, actually here, because I commented out these things. Even earlier, maybe. No, these are just expressions, right? No, they're not. Trying to calculate using an FA here. Let's see what the next compile error is. I don't know. Valid operands to binary expression symbol in FA. Oh. That's quite early. So C2 is a symbol and C3x is an first approximation object. No, you can't add them. I think I'm gonna fix... I'm gonna start with fixing the writing it to an O-stream though. Operator. Oh, print on. Printing the thing. Well, that used to work as follows. If the zero order is not 0 and the first order is not 0, need parents, symbolic constant is 1, common denominator, of also not apparently. Okay, I can't follow this at all. So the thing that changed is the first order is now changed from a symbolic expression to an array of symbolic expressions. And this line checks if that is 0, and this one also. So let's just do that in advance, because make a boolean, first order is 0, and then we can make a for loop. It runs all over all the what I just generated a page of code. I'm so not going to use that, of course. I don't believe it. But okay, we can copy this one. And I is less than the number of epsilons. Nah, no way, man. I need to run over all the elements of that array. How do you do that? Epsilon index type. Let's call that I then. Is no, it doesn't know my library. Damn it. First order dot C begin. I is unequal first order. I'm not sure about the I C now. Actually, is it not I? It's an I actually. Plus I. Stuff. Now it must also be an I. So the array has an I begin. There's a user detector array here. We have an I begin and an I end, which returns our epsilon index type, the index type of the array. So I use that, and then we test something, and if it is non-zero, then it's going to be non-zero no matter what follows. So if something, then whoops, then break. Well, actually, then apparently first order 0 is false, and then break. And it is non-zero if, well, of course, yeah, this. No, not really. I just want to go to the end of the line, actually. Oh, that's better. And not, yeah, this is correct. But why it repeated that, I don't know. I already had that. I'm gonna use my code. So if the pointer is not null and it references something that is not 0, then we have at least one non-zero thingy. Which means that now we can replace this. And this is if not is 0. So if not, first order is 0. And then here, of course, the same thing. Yeah, no, yeah, but a million lines of code. I think it's crazy. And then we have to print it. Now it gets more interesting. You have at least one thing to print because it is non-zero. So we can print the color code, and then print the first order thingy, and then print the end color code. However, this thing now is an array, so we have to loop again over the whole array. and then only print it if obviously it's not a null pointer. Maybe we should also test if it is null itself. Null itself, don't want to print it. Maybe. Okay, so how can I use this but not everything? I guess I can just copy it. Blah. Bloop. Did I miss a parenthesis? No, I didn't. No. So if the first order array entry at index I is not null, then we print it. And that thing is then, of course you just print I. I thought I keep pressing escape when it is correct. So on top here. But we have a need a multiplication here as well. This is not. I want to print this as an actual index. That should be possible, shouldn't it? Do not have that somewhere. I think I have it. Yes, I have it. How do you call those things? Subscript? Subscript. Nope, does not get a color. Maybe it was into subscript. I need multiplication with it. It's not clear if there must be parentheses around this thing. Parentheses shit is so difficult. So I want to print this and then you have to multiply it with an epsilon. And then you have to do the pluses in between, or maybe it's a minus. So the same difficulty as I had everywhere else here. Keeping track of we need the parentheses, and if we want a plus or a minus, horrible. Let's for now just say we do a dot here times epsilon. Oops. Oops. God, what happened? I switched here. Where's my cursor? There. Dot epsilon. And I think I have something in utils these days. Huh? No utils. Oh, we're already there. Here's utils. I thought I added something. But where? Why would I have edited you this? And what is the name? And how can I find it back? I don't think it's in utils. in machine learning, maybe somewhere. Here's an array with subscripts. That's in a test. No, that is buried very deeply. If I wrote it this way, then maybe I can find something back. It uses double quotes around it. How else would I store that? Let's do one more search for something with double quotes around it. I could print more than just 0 to 9. I could print any integer. So how's this thing working then? It's just a printle. Yeah, that's what it is doing here. Stupid. It prints the superscripts. To turn this into some kind of utility so I can use it more often. No, for now I'll just copy this. It's sad but true. But I is of type epsilon index type, so that means that this thing also must be a utils array that uses well, there's a number of epsilons size and epsilon type index as the index. That should work. Okay, so we can still not add these two things together here. What was it? Expression plus an FA. add operator plus expression. This is FA plus an expression. What was it? Really an expression plus an FA? No, I'm not too sure anymore. Yeah, it's symbol plus FA. It's not expression. Symbol plus FA. So there must be a friend operator then. Friend plus expression FA. Is that it? I think so. There's no other friends. So let's release these two friends here. And I just swap the stuff around. So now it becomes an FA plus an expression. And here it's minus FA plus an expression, which means that you must be able to negate an FA. Maybe we should do that first. No, it looks like a low-hanging fruit. Let's not do the evaluate yet. Where's my unary minus thingy? I can't find it. Okay, now what? What's the negation of the expression? No, it was FA. Here's negation. Right under my nose. Okay, I'm just gonna move this down here for the moment. To negate this thing means that we negate the 0 one, and whoops, the first order can't be negated. You have to negate each and every element of the array. Yeah. We'll make an FA as a result. Yep. And I'm gonna fill that with okay, let's construct this from already the minus 0 order and the common denominator, ignoring the first order for the moment. But it's kind of weird, so maybe should make it a private constructor. Just add it here. So we make a private constructor. That was this one, and then we are negating. In the end, I'm gonna return a result, of course. Okay. So epsilon type I, first order I begin. It did remember that. It's pretty embarrassing again. First order n plus I. If first order I is unequal null pointer, then first result first order I is in the negation of first order R. Yep. Except that it is a pointer. Result is first order. R must be a pointer, so I think I have to do this and then this again. I have the negation, so now this works if the plus works. So now we have an FA plus an expression. We don't have that one yet. That it means we need FA plus expression minus, yeah, this one. Yeah, that's correct. The argument that you pass is does not have epsilons in it. I hope the comment says so. So then we just add that to the zero order approximation. Multiplied with the common denominator, because we're also dividing this thing again by the common denominator. And the first order thing is just left alone. This should work. Let's see if my compile error shifted to the next line or something. Or what happens. No matching constructor for initialization of FA. Yeah, again, it's a copy constructor-ish thingy. We don't have that one. No, it's not a copy constructor. I'm rambling. We need a constructor for also the first order. Let's move my constructor up. Close to the other constructors. I left a public, stray public. It's no longer necessary. Okay, now I want to pass the first order. What the type of the first order is what? An array. No, that sucks. It's a big thing. The whole array here. Const reference. First order. Doesn't fit on one line. Tills array, blah blah blah. It's just too long. Yeah, I know it's still too long. No matching constructor initialization of FA. Still that line. Strange. Well, no, yes. Shouldn't it be this one? I think it should be this one. Expression, comma, epsilon index type. And E4 is an epsilon index type, and this is not an expression. No, it's not. Okay, yeah, the constructor was for this one. Now we turned this one is the return type of the addition. So you have an expression plus an FA, that is an FA. So this FA plus an epsilon index type. Almost the same thing. But not an expression, but an FA type. I don't know how I called that, or how I called that before. Construct. It just never existed. In that case, I'll have to make up the name now for it. Just call it FA. I think I've always saw that before. Fucking hell. Stop. That's okay. I had a space and hope that it shuts up. No. That worked. First order epsilon index. It kind of depends if it is 0 or not. Let's do equal null pointer. That's the part that must be multiplied by the epsilon. Therefore, we only take the 0 order. Otherwise, you would have epsilon times epsilon. Do I think that's correct? The 0 order is a reference, and we store pointers in the array. So I take the pointer of that here. I think this is correct. The first order. It's not correct, is it? You know what? I'm pretty sure it must be 0. So you can just do this. I'm gonna make an assert here. Hopefully. Order. FA. That is with the times 1, and then we have the times 1 the first order. This is just times 1, and now we do the times 1 plus epsilon, so I have to multiply the whole thing by epsilon, which means that the FA0 order also has to end up in the first order at that epsilon index. Yeah, looks okay. What are we doing here? Invalid operands to binary expression FA and const symbol. Yep, all the operation types are going to fail. Hey, we went one line down. There is progress. And this one is multiplication between, I forgot. Well, this is an FA times an expression. That would be this one. Wow, it's again smart. It's fucking smart suddenly. Why? Oh. Fill this one in. Nah, come on, fill it in. Oh, there it is. Took a while. Yeah, we went over everything, and then if it's not a null pointer, then it's... You gotta be fucking kidding me. It just learned that for me. To use the ampersand here. Dereference it, multiplied with the argument, and then dereference. This is really intelligent. It's just I can't say anything else. I'm impressed. Scary. Yep, well, that's how I would have written it, I think. Okay, now what? Expected brace close. Can't divide. That is FA divided by FA. Okay, let's use Copilot. It might even be smart enough now to fill in everything. I mean, the last thing I did was really smart. Let's try this. So let's see what it does if I just copy this, paste it, and then go to this line. It does something. Subtracting expression does not contain epsilons. Yeah, it's actually correct. In other words, nothing changed. This one. Multiply with an expression that can contain epsilons. I think this it failed on this one. It just copied what I already had here. I'm afraid. What? I want to know what it says. So I'm just no return. Okay. It's 2 loops. It's a bit weird. Okay, so we initialize 0 order times FA 0 order and the common denominator, but not the FA first order. Yeah, I think that's correct. And then it loops over all the first order expressions. And if the current one is not null, then the result is set to the current one times FA 0 order. Yeah. That's this part. And then we run again over it, and then it says if A first order is unequal null pointer, then we add do, then we set it to something. Well, that could overlap. So this is the 0 order. Why is it dereferencing the 0 order here? Got highly confused suddenly. So this is the 0 order times FA first order. So that would be this part. However, it only does it when it is a null pointer. Now, if this is a null pointer, you don't have to add it. I understand that. But, oh, it actually, this is a null pointer, you don't have to add it either, of course. Because there's a multiplication with it. Yeah. But you can't just assign it. That's not correct. We have to add it to this. No. Wait a minute. Well, actually, yes. No, that is... yeah, not testing result. If result first order is null pointer, then we do the assignment. So this should be the same as that, which it not is. Yeah, that's bullshit. This should be 0 order, and the reference should be gone. Dereference. And if it is set, then it should be set to adding the dereference thingy plus the same thing with the same error. So it is more or less good, but this should be 0 order. Oh, that's gone. This must be... Oh, wait a minute. Wait a minute. There, here, I mean. Oppo. Ja. Nou, let's ask it for the division here. That's correct already. No, 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 no. No. What's that bullshit? Or am I wrong now? Wait a minute. I thought, no, wait a minute. The minute. This would be the... Which one is this? I want to reconstruct this per element. And this is first order I times FA common denominator. So this is the first element. think it's correct actually. Yeah, what? No, what is it doing here? Result first order I equals null point, and we're going to do an assignment. And the assignment should be the thing that we didn't do yet. And here we do the result, so there's assignment already. Do first order times common denominator, so that would be this one. So we did not do this one yet, that is SFA first order times common denominator. What is that? That doesn't make any sense whatsoever. FA first order times common denominator, that's better. And then of course this must be the same thing, plus FA first order times common denominator. So we'll never know if it is correct. It's too difficult. I think you have one left. It keeps doing that, dude. What the F? What the F? It's 0 times FA 0 order, and then it continues with shit. This is also shit. Okay, so you run over this thing, and then if first order I unequal null pointer, we can do this one, I guess. So then result, yeah, this is also wrong. Also nonsense. It's just guessing now or something. Result. So If the result is still null pointer, then we can assign it from first order times FA0 order. That is first order times FA0 order. That's this one. Otherwise, you have to add it. So now it's a the pointer to the dereference of result first order I. But that's complete bullshit. This is not useful anymore, right? Oh, no, it has it right. Oh. Yeah, well, no, not really. This must be dereferenced. Plus, and then I want to have the exact same expression as here, of course. Yep. But now we only added this, not the second one. So I think we need another loop. Which checks the FA first order. And then if that is unequal null, the result must again be checked, because that's the only thing that's being updated here. Now I'm confused, and the other one didn't do that. It's not dereferencing it again. Zero order times the runs of every first order. Yep. Okay. Yeah, I should probably write a separate function, because this is kind of code duplication here, to test if it is 0 or not. Hell, the whole for loop is code duplication. And then it would be a lot less error prone as well. Of course, I duplicated those things now quite a few times. So there's something missing here. Is it not possible that the result first order is already assigned here? I guess not. Result is initializes a null array, so then it's also not necessary to do it here. The result is normal is always the case, actually. Class member cannot be redeclared. Yeah, I did copied it. No variable overloaded equals. Yeah, that's true. Of course, you can't do this anymore. I have to do that in a completely different way now. This has to do with evaluate, so we're going to start with just delete it. Epsilon index. Let's see how that is being used. Okay, EPS variables, EPS plus 4. Yeah, I'm using it for variables. I don't have it in variables anymore. Nope. So that is nonsense to begin with. Oh shit. Oh shit. This should help. I broke the whole program to begin with now, because I can't take the derivative with respect to the epsilons anymore, because they are no longer symbols. Well, I'm just doing an evaluation here. No, I'm also doing a derivative here. Taking derivative with respect to the epsilons. So this whole piece of code has to be rewritten. I think this is a copy, by the way. Let's remove this. This is this block of code. Okay, let's comment it out for now. No member named expand in FA. Yeah, that was the last one that I did not implement. Verify the above expression. The TA. What does expand mean? I think it just gives me the expression. Or that does give me the expression that then I can verify, which I then can differentiate and evaluate and stuff. So I'm already taking the derivatives here with respect to the wrong symbols. Unless, of course, we reintroduce the symbols, and I do make my expand such that it does that. I can do that. I can do that. Just have to make the epsilon symbols again. No, I think I'm taking the derivative with respect to this C. Am I not? The question is, what is the I here? That runs still 3. Those are the C's, I think. That should still work. Not to mention, well, yes, of course, that does still work. So variables here, 0 to 3, including 3, the first 4. The first 4 variables, and they are they're probably in a sign somewhere here, variable. number of variables. So it's in the variables here. For each declare variable. Declare variable is just the name of this thing. So there they are. The first four are the C's. Haha. Hi Sam. So I want to decide to do the same. Is the programming, i.e. source, strictly for pure math? I don't understand you. It's programming, so how can it be pure math? What I'm doing is, how do I formulate that? I'm working on writing, I'm working on something and then I need something. And for that I need something, and for that I need something, and for that I need something, and for that. So it's a rabbit hole that is so deep that I'll never see the surface anymore. But somewhere half of deep inside the rabbit hole already, at some point, I needed a function to give me the roots of a third-degree polynomial accurately for any polynomial coefficients. And I'm approaching the roots of that using Haley's method, which is one step better than Newton-Raphson. And it turns out that if you do, well, in this case, I'm explicitly working on Newton-Raphson. As you can see here clearly, it's Newton-Raphson. That you see it here clearly. The new x becomes x minus the f divided by the derivative of f. But you don't get infinite precision with this Newton-Raphson because of floating point errors or floating point round-offs. And this program is trying to calculate exactly how the floating point errors propagate. So, for example, I do C3, which is a constant, times my x as a start of calculating f, which is a f. Surely I have a comment with f in it. No, well, this is my f is the third-degree polynomial. I was sure I had it somewhere, but yeah, here. Well, it's just not a comment. So we have the third-degree polynomial, and we begin with C3 times x. That's the start of calculating this third-degree polynomial. And then we mimic the floating point round-off error in with an epsilon 5, where the epsilon 5 then depends on the values of C3 and x. But we pretend that we multiply this exact mathematical result with 1 plus epsilon. And then magically the result fits exactly in a double, all right? So, yeah, basically you just add epsilon times this value, and then the negative of that is what was cut off. But instead of doing anything with values, I'm doing it symbolically. So the result of this is an extremely large formula, which is not human processable anymore. I'm glad I can even print it. But the computer can still work with it. So I'm going to investigate then what it exactly means. And I already know the answer. Probably it's something like linear with the derivative. So I want to see that. But then there are, special cases, or how do you say that? Corner cases. where also something happens independent of the derivative. So maybe you can find them all. Yeah, now I've got what I was doing. That's how it works. Wait, expand. The expand. So it would be nice if this expand returned a symbolic expression, including... No, I don't need the epsilons. But yeah, they do include epsilons. Except I want to set all the epsilons to 0 anyway, right? But if then I take the derivative, I have absolutely no clue. Huh? I think, okay, this is not that easy. Or is it? Can you set them to 0 in advance? If I set all the epsilons to 0, you just get a 0 approximation. I don't know anymore what I was doing here. So this would be the 0 approximation, at least of the GA times the derivative squared. And then everything else is multiplied by an epsilon. And I did set all the epsilons to 0, so yeah, then you only have this. But I'm pretty sure that the program is checking if these values are correct by taking the derivative with respect to C1 and C3, for example, and then you get that constant out of it. Oh yeah, of course. Now I understand it again. Taking the derivative is independent of the evaluation. So I just take the derivative with respect to C1 of the whole thing, and then with respect to C3 of the whole thing. And then we fill in x is 0.1 and we fill in epsilon 0, which means that everything drops out except the minus 4 that we then have. So this is 1. These two are removed by taking the derivative, and everything else still has an epsilon in it. Well, man, it's not that easy actually. There are other things. There are higher orders of x still in it maybe. But because I set x to 0.1, I can zoom in on the portion of the result that is probably x to the power 3. So you get 1,000 times, so you get 4 thousandths. This is a minus 4 thousandths. And then there is also 100ths and tenth and 10,000ths and 100,000ths and stuff. But we can all cut it off. So you just look at the thousandths thing. So that's how it extracts then the 4 out of it. But I repeated these values in this array, and it simply runs, does the derivatives, and then it asserts that it is equal. And it worked. So this formula is correct because what I have here in the comment is reproduced here in the array, and it was already checked to be okay. However, it would be nice if I could change this program in a way that it's still checking that. But it means that I must be able to take derivatives, I think, and keep the epsilons intact, while keeping the epsilons intact. I think I can only take the derivative of a symbolic expression, which means that I need the epsilons as symbols, and I got rid of them. I can add them back, but it's too late now. I think I'm gonna go to bed. Or add them back differently, I mean. I removed them from this list here. But I can add new. I can add symbolics for symbols for the epsilons back, and then explicitly use those during the expand. So my expand here is doing this, or was doing this. So the zero order is well, that's evaluate. Sorry, I need to expand. Just expand. Yep, so the zero order is a symbolic expression, and the first order is a symbolic expression. And I have them separated in this class, so I can keep track of second orders. So as soon as you do first order times another first order of another object, then it becomes second order, and then I just throw it away. But if I just want to turn the whole thing again into a symbolic expression, basically they just have to be added and divided by the common denominator. This is the underlying expression of the FA object. However, now this has become an array, and I don't have epsilons anymore. So what I want to do is make what I should do is something like okay, I want an expression. Which is never easy. You can only have expression references. Can't make a result. Yeah, you have to add multiple. Each element of the array has to be added. So I can't do that in line. So we just have to introduce a lot of references then for the temporary expressions in between. Yeah, I'm afraid we have to do that. I think so. You have to add it, and now let's add an. Could make a pointer again, I think. So let's not work with a reference, but we just work with a pointer again. And then that's okay. That's going to be the result. So now we have a pointer that points to the zero order thingy. And then I want to add all the first orders to it, like here. But now this is an array, so we loop over all the array elements. And if we have anything at all, because array elements are pointers, so the pointer must not be null, then the result is set to point to the result that we had dereferenced, which was initially zero order, plus the element that is not non-null that we found. And we do that in a loop, so this is leaking expressions as hell, but it doesn't matter. They're never freed anyway. And then afterwards we have added all the first order elements, except that these first order elements have to be multiplied with their corresponding epsilon. So you have to multiply that with, yeah, I don't have that, but it was nice try. I'm gonna make it an array though. Let's say I'm having an array which is also a pointer, so I have to also do references probably. So I just multiply that with the epsilon symbol that we have there. And then in the end we still have to divide it by the common denominator. But now I can just do let me see. This can be a reference. So I just dereference the result, which is a pointer, divided by the common denominator, and then we can return that. But the problem was I don't have the epsilon, so now we have to create the epsilon array, which takes an epsilon index type as index type, which means that it is. Can I make it static here? I'm not sure. Probably should not do that. So this must be symbolic. Symbol. Yep, that's correct. Except I called it epsilons. No, I called it epsilon. Yeah, it still has to be filled. Now it's filled with zeros, 0 pointers. I'm going to be lazy. I'll just pass it, I think, to the function. To pass array as a const reference. And then when I call expand, we have to pass the epsilons. Epsilons. And then I have to declare the epsilons. What is it doing? A pair of an expression pointer and an epsilon type. What? No. Yeah, that's what I want. Not too bad. Yeah, we have to fill those things now. How are we going to do that? Oh, like that. Run over all symbols and then... No, that doesn't work, dude. That does not work. I need, sorry, epsilon index type. That's what I want. That's a pretty impressive again, that it understands that it has to do it like that. I guess it learned that from this line, but still impressive. String I. Yeah. Yeah, okay. Except the toString I doesn't work, I think. I'm not sure. Yeah, you get a hashtag in it. Let's turn this into an integer first. toInt. It doesn't get a color. How do I turn an array index into an utils index? array index to int to just get value. That's lame. It compiled. Okay, I'm going to bed. No, I'm just kidding. Let's try to run it. Just one time. It was called epsilon sums. No, it wasn't. Newton epsilons is it? Looks like you're printing pointers instead of dereferenced first order thingies. So this is FA. So A stands for approximation. F is the function, which in this case is the third degree polynomial. And then the not colored part is the zero approximation, which should be the exact mathematical approximation. And it is, well, it still is. It is just C0 plus C1 times x plus C2 times x squared plus C3 times x to the power 3. So this is my third degree polynomial. And then each of these operations that we used here introduce an error, and those errors are then printed here. And they are almost correct, as in that they are something multiplied with epsilon 0 plus something times multiplied with epsilon 1. And so on until we have all epsilons corresponding to the floating point operations that we needed to do to calculate this, which are 6 in total, namely the first x, and then the plus, that is 2, and then the next x for here and here, so that is 3, 1, 2, 3. And then we get this plus, and that is 4, and then we get this x, that is 5, and then we get this plus is 6. And we have to fix the print. So these are pointers, you have to dereference. And yeah, and then the question is it still correct? Well, we definitely need parentheses, because it does plus, and then we print the first order approximation that has to be multiplied with epsilon 0. So this whole thing must be multiplied by epsilon 0. Now, if it is just a single thing, then we wouldn't need parentheses, but I bet it's just gonna be something that has a plus or a minus in it all the time, so you might as well print the parentheses all the time. The formula is a bit small though. Or maybe it wouldn't be larger than that comment, which is kind of the same size as the comment, maybe. I'm confused. Well, anyway. I think that the best way to verify if this program is still working after this big change is to just finish the whole program. What the fuck? Oh, I did comment something out. That is true. I mean, if it makes it to the end, but there's already an assert here, so I'm like, what? That assert is not failing. Apparently that assert is not failing. So that kind of already proves, I think, that I already took derivatives and verified them. But okay, get a part with epsilons. But if you fix this part, and also these asserts don't fire, then I'm convinced that it is just working. It's kind of impossible that then there was a bug somewhere. That means that that I just checked that this formula is correct. By doing all this, well, they must have been doing then the exact same stuff as before, although I store it differently. So what this is doing is taking the derivative of the GADF2 epsilon, which is the GADF2 minus the GADF2 no epsilons. So then you get just the part with epsilons. And the GADF2 was already checked, I think, then, wasn't it? Let's see. So that's a GA divided by the square of the first derivative. Yeah, so this is an expand. This is an expand, and this formula I didn't touch it, so this is definitely correct. And this is yeah, this I would say it just works. But okay, we can do this. Maybe I'll sleep better. Trying to understand what is happening here. I do have symbols added. Yeah, this thing does not have epsilons, and this one has epsilons. We just added it. Should this work? Except I'm not assigning the epsilons to 0 now. Okay, well that would be a reason for the asserts to fire. I think it will compile, but the assert will fire because I didn't set the epsilons to 0. Let's try it out. It compiles, run it. Segmentation fault. Segmentation fault is not the same as an assert. So it looks more like a dereference or a 0 pointer or something. It also makes sense. This pointer is 0. Okay, that will do it. Up. Oh, okay. I'm trying to change epsilons here by accessing variables, but I removed them from variables. So maybe I should not have done that. we should not have done that. We can put them back in variables. Why not? Okay, I can do that. So we can look at the diff. And then we'll see that somewhere I removed this shit. So we add this back to the for each variable. So added a thing for each or not. What are we talking about? Yeah, what? Oh, never mind. Okay, by doing that, we have added back. We have them added back in the class variables. And we can print them, and we declare the symbols here, which means that now I cannot do this anymore, because they are now declared here as symbols. So we're going to rename these things to index. Let's say substitute all the brackets open with an I bracket open. And then the question is, where do they use them? Okay, I use it here. Just put an I. Well, actually I can do that also very quickly. 1, 2, 3, 0, 9, yeah, all of them. Okay, substitute that thing with an I with that thing. That should do it. And then we need an array. Yeah, I need on this array here. So we had an epsilons, which now they should not be realized anymore. I just want to copy them from variables. So we have variables. Holy shit! But how does it know that? Oh my god. So this is, yeah, Copilot. It just fills it in. Well, almost. It won't work. It won't compile. But the idea is correct. So the first index, we have E0 defined in variables, which is enum class, so the variables must in front of it. And then I wrote in a toIndex, which takes that variable and then casts it to an int. So then we have an int. And I want to add that int then to, well, the index type. So you have to do that as a get value. No, get value, yeah. That's then also the int. And that is then the index into variables. And the variables itself contains symbol pointers. So now we have them. Okay, pretty cool. Now we have an assert. Very nice. Well, nice. Yeah, I wanted an assert. Yeah. So it compiles, it runs, and it asserts on this assert here. And I think that the reason is that I didn't set epsilons to 0. So I can also do that. I think that was, I did that here, right? Out below the x. So now here I must run over all epsilons and then just set them to 0. So I do 4. No. No, 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 no. Try again. No. Yes. That is correct. Oh, wow. Yeah, that's correct. I'm impressed again. Damn it, still a third. Ah, too bad. Okay, that sucks. Yeah, what? Down. Down, down, down. Down is down. Befriend. Some reason. Huh? What? It's the third anyway. Nobody gets it. The estimate is -1. Would have been nice to know what it should have been. I can figure it out by just resetting the code to before this change. I think that's the best thing to do. Just run 2 programs in parallel. One that has the correct values and this one, and then we can see what the difference is. So let's move to. I want to keep this one. Take a new tab. YouTube. CDA. Oh, yeah, I see XX. Math test suits. Git K. I didn't commit anything, right? So this is still all working, I think. It's just master. Did not commit it though. I didn't push it. I think I just want to make a new checkout. Yeah, I need 2 source. Sorry, two source trees. And so maybe I should. I just push this, I think. And then let's clone a new one here. Oh, it was already here, yeah. I can just make a copy. So let's say copy this thing to. It's kind of scary to copy the whole Git database though. I don't think it's a problem. Test. So now I can do git restore dot. I have to change my repo base. dot test. There's no test in there, so it's not working. Just built there, I think. Cross fingers. Should probably erasing my hard disk now. It's also the wrong one. So we must run this one, but then in test. Dot test. Yep. So this one did not assert here, so we can run this one now in the debugger. This main. So let's set a breakpoint. I'm gonna assume that I is 0. Let's go here. I left it, okay. Was that this V? Yeah. It was that one. Run. Oh, we already, sorry, no. Up 7 or so. Print I. I is 0. Obviously, it's just the very first time. Not probably the very first time. The next loop is J. Print J. 1. Well, it begins at I. You see, the first one, something succeeded. And K is 4. Wow, okay. No, I don't know. Let's just set the breakpoint at 320 with the condition that I equals 0 and J equals 1 and K equals 4. Run. Next. Eps. Eps is 6. Oops. Print eps is 6. Variables. We set variable. We set one of the epsilons to 1. The rest should be 0, by the way, but I think that it should work. And then we evaluate the estimate. Estimate is 1, not -1. There, it is wrong. And then can I print this? Factor, standard power. There's no power in standard, it says. Yeah, right. Zero. Okay, that makes it slightly easier. This is just 1 then. 1. Okay, 1 is equal to 1. So definitely it has to be 1. But we did get -1. Damn it. No, I cannot print this, of course. That's not really what I would call printing it. I want to print an expression. Maybe I should just do that in the code. Probably can do that from the debugger as well. If I add some function, some global function that does it. I might as well do that, but I'm probably going to need that more often. So we go here, and then I want to be able to print. Yep, no support for that yet. So let's say we call that, it's just some global function print. And it's going to print what? Symbolic expressions. Yep. I think that should work. And I forgot. But, oops, no. Wrong button. This one. Yeah, I could not have remembered it. That is minus epsilon 0 minus epsilon 6. And one of the epsilons is being set to 1. So how can that become 1? It should be minus 1. Oh, the expression is wrong. Of course. Which means that we have to print here the real expression, the actual expression. And we can't do that because I don't have that function here. That sucks. Nope, did not do it. Thought I was smart enough to understand that I wanted the same function, but didn't. Symbolic expression. Nope. It's not print on actually. Yeah, that's better. Huh? Just current context. No. Okay, I'm a little lost here. Oh, I put a break on the 320 instead of... Not a break here, 325. Break 325. Condition 2, I, no, j equals 1 and k equals 4. Run. Estimate is 1. Call print. Aha, okay. Close but no cigar. This minus E0 plus E6. You would say that epsilon is 6. It is, yep. So epsilon 6 was set to 1, and then this expression becomes 1, and that's what it should be. But here we have minus epsilon 6. Why? Well, this thing came from that is dg dci dcj. It probably has a meaning. Here it is. Oh, derivative. Oh, that is just the the g approximation divided by the second derivative, or sorry, the first derivative of f squared. Partial derivative of that with respect to ci, and then the partial and cj. So if we know what this is, so you have the partial derivative of this thing with respect to c0 and j was 1, so c0 and c1, and then I get minus e6. What the hell? What the hell? You got to be kidding me. Yeah. Oh, wait a minute. No, of course. The derivative function just works. So this whole expression is already wrong, indeed. The derivative with respect to C0 and C1 is just minus E0 minus E6. And the rest becomes 0 because it's not depending on both C0 and C1. So this expression is already wrong. And we can see that if we go here and do call print. Well, that one, there is a plus here. No, that's already wrong. So then now the question is, where does this expression come from? Well, control top. That would be this one. So probably that one is wrong. I mean, that's the only one that was changed. So this should still be the same as in the other one. So you call print no epsilons. And we do the same thing here. Let's just copy it. And that should be the same. Well, looks totally the same to me. Nothing changes. Therefore, the change, or the difference, I mean, must be in this one. Among other things, we have a minus here. While here we have a plus. Yep. Next question is then, where does that thing come from? Let's go here. Comes from this. Yeah, then I want to print GA and DF, I guess. But I now also need to be able to print FAs. Because I think GA is an FA. They both are. Yeah, it's the way it is. I'm impressed. I think Copilot was looking over my shoulder when I was debugging. So even using const, east const, what do you call that? You think GDB will call the right function? Yeah, it will probably call the right function. Start with df. Yeah, that's just right. That is just right. Let's print the other one on GA. Okay, that work. So something would be wrong with epsilon 6. So I have here, where's my epsilon 6? Here's epsilon 6 is multiplied with minus C0 times C1. So yeah, this is then apparently wrong. I mean, I don't have to look at the other program anymore. I just know that this minus sign must be a plus one. So now I have to figure out when did this minus sign appear here. Now it gets harder and more annoying. GA. So where does the GA come from? Well, I can look at the source code maybe. Let's just abandon this directory for the moment. Let's look at the source code here. GA here. Oh, see, we're not done. We can just keep printing stuff. Although I cannot compare them. That's... yeah, well... might become annoyingly hard. Epsilon 6. Where does the epsilon 6 come in the first place? There. Oh, interesting. So it comes from the DFA. So it would be nice to just print the DFA in both programs, I have to admit. It's a reasonably small thing as well. Well, the epsilon 6 comes from there. Still, I'll probably have to print them in the other program as well, in order to understand what's going on. Okay, I'll do that. I had it compiled, run it in the debugger, and then breakpoint 3 something. Was it 325? Nope. Well, in the meantime, it's become 330. Condition 1, j equals 1 and k equals 4. Run. And then we can do call print, and I want to compare the DFA. C1 plus 2 times C2 times X plus 3 times plus. Yeah, that's hard to compare. Let me just copy this. Let's do it the other round. This one is correct. This one is correct. So I have C1 times epsilon 6. Two times C2 times X, 2 times C2 times X times epsilon 6. And then we get an epsilon 7 there, and another epsilon 6 there. 3 times C3 times X squared. All the epsilon 6 factors are correct. In fact, it looks like all of them are correct, because I don't see any minus signs anywhere. Okay, let me check this like completely. 2 C2 X plus 2 C2 X C. So you already checked that one. That was this one. C3 X squared. 3 C3 C7 X squared. 3 C3 8x squared. 3 C3 9x squared. Yeah, it's completely equal. So the problem is not the DFA. I'm gonna bet it's a division, which means that also the FA is probably going to be correct. FA. Let's copy the one that is correct. This one is correct. That here. C0 plus C1 X plus C2 times X squared plus C3 times X to the power 3 plus C0 times epsilon 0 plus C1 times epsilon 0 times X plus C1 times epsilon 1 times X plus C1 epsilon 2 times X plus C2 times epsilon 2, sorry, epsilon 0. So C2 times epsilon 0 times X squared. C2 X squared times epsilon 1, and we have C2 X squared times epsilon 2. And we have C2 X squared times epsilon 3. And we have C2 X squared times epsilon 4. C3 X to the power 3 times epsilon 0. C3 X, same thing for every epsilon actually. Okay. No, they are equal. Yeah. It's amazing, but that one's also equal. Yeah, the division must be wrong. I think. But we did more. Well, I completely lost my formula, of course. We did do more. We also did a subtraction to this formula here. So this one is wrong, this one is correct, oops, this one is correct, this one is correct, and this one is correct. So it's either that one or that one. And this is the only place where a division happens. It's probably the division. What can go wrong with the minus? Nothing. Just a minus is correct. Don't believe it is the minus. Nah. Let's have a closer look at the division. I should have been in bed like an hour ago, but... Okay, that one, I'm in the right directory even, so the right tab. I'm going to have a closer look at the division of class FA. Division. Okay, so the current object is this, where Z1 means the zero order, and the F1 means the first order multiplied with the respective epsilons, and the D1 is the common denominator. And we want to divide that by the FA, so then you get FA zero order, FA first order, and FA common denominator. And this should be the result. Meaning, this is the zero order, this is going to be the second order, I see it coming, and this is the common denominator. And we start with constructing the result with this, where this is Z1 and this is Z2. So that would be this part. And then the common denominator is also initialized from Z2, which is FA zero order squared, times the common denominator times the FA common denominator, which is D1 and D2. And then all we have to fill in this block here, this part. And we do that in 2 steps, 2 for loops. One takes care of this one and the other one takes care of that one. Now here we see that it is you doing our first order times the FA zero order. So that would be Z1 times F2, which is this one. And there is no minus sign inside, so that is the bug. Minus that. And now we fix it. But let's check the other one as well. Oh, this is just plus, of course. This is, yeah, I don't know what the fuck. This just, that was it. Make, run it, no asserts, go to bed. A fucking still assert. Got no progress whatsoever. What? We did a step back. No. Why? We used to get till case 4. No more. Yeah, I'm gonna go to bed. I'm totally going to bed. I'll have a look at it tomorrow. ASMR. I'm just too curious though. What the hell is going on here? Maybe there's another bug which was cancelling the first one, and now no longer. Is that equal to the previous one? Do we still have this in the scroll back? Compile. There it is. Still have it in the scroll back even. So I can also check if, say, FA was changed. What? Select. And not highlighted. The universe is against me. Ridiculous. Well, of course it is working. The only thing I changed was a minus sign. And there are no minus signs here. Hell, the division wasn't even used yet. So yeah, this is the same. Let's just print what the last thing. I mean, this is just, I know that I fixed it. This is now minus epsilon 0 plus epsilon 6. It is the other way around. What? Okay. We did change something, but the wrong one. What? This was minus epsilon 0 minus epsilon 6, and I changed the minus sign, and the epsilon 0 got negated, not the epsilon 6. Yeah, well, maybe the subtraction is wrong too then. Maybe. I mean, that would be a good coincidence. So we corrected this one, but this minus sign is resulting in a plus. That would explain this. First, I'm going to look at the division again, though. Yeah, I did it wrong. F1 is our first order. So our first order times the zero order of the other. Set F2. That, wait a minute. Yeah, this, Joe, yeah. So this thing is, this is Z2. This is F1. So that one. So I negated the wrong one. That is not negated. This one should be negated. Brilliant. Exited normally. We can go to bed. It's just fucking running correctly now. Okay, so I changed the class FA now to store all the expressions per epsilon, and then it's printed like that as well. So we just have an expression times epsilon 0. Epsilon 0 is here. And they have another expression times epsilon 1, and we just keep track of those expressions. The expressions that are to be multiplied with all the respective, something is wrong here, till there, will the respective epsilons, yeah. And then what I can do now is simply square all those, well, the value of all those expressions in front of the epsilons, sum them, multiply them with 0.844 or 45, what was it? And then we have the error range, or the error range with a chance of 50%. The range that has a 50% chance that the error falls inside of it, something like that. By approximation, more or less. At least the formula will explode like crazy, but we got rid of all the epsilons. Okay, we have to do something like this. So introduce, you have two more epsilons I need now. Number of epsilons is now 12. Is that even going to work then? That is only going to work if I have epsilon 10 and 11, I think, as well. Which is going to be a problem, for at least here, for the moment. So I need, yeah, thank you. 10 and 11. And you need to expand this one. Oh, that already have them, 10 and 11. Yeah, that's gonna work. Okay, I need to make this one 10 and 11. Come on, you can do it. Yeah, okay, there's one. And the second one. And then over here we can do, I can construct it from, well, they first have to do this one actually. So that is FA, FA diff DFA. Be constructed from the mathematical expression and epsilon 10. Where does this come from? No epsilons. No. Complete nonsense. No. Oh, it thinks it's just a square. Yeah, that is too. It's kind of a problem there. I didn't mean a square. Oops, stop and then fix it. X minus that one. Let's print that as one as well. I want to see a big formula working for nothing. It's not even that much bigger. Oh, wait a minute. It prints a DA diff. That's not, I want a GA. GA tie 2. But yeah, that one will be hardly any larger. No, it's not larger. It starts here.